less height, right?
Yes.
Less height, and the one we have from the roof to the ground, that one has more height. So if you think of 1 square centimeter area on the table or on the ground, that time the number of air molecules you have on the table is less, and number of air molecules working on the air column, which one is on the ground, that is more, right? Every square centimeter, isn't it? Hello,
Hello?
do you understand what I'm saying?
Yes.
So do you agree what I said?
Yeah.
Okay. If your number of air molecules are more on the ground, if your number of air molecules are more on the ground per square centimeter, then we can say the mass of the air molecules, the collectively all the air molecules mass, that is also more, right, on the ground,
Um, yes.
isn't it? If the
Yes.
mass is more, then the
So pressure will
weight
be more?
of the air molecules also more.
Yeah.
If weight more, then we can say force is more, right?
Yes.
So force per unit area, it is pressure. You have both the area same, but the weight of the air molecules on the table less, but on the ground is more, right?
Yes.
So what can we say? Your uh, air column we have in your house, that one has more pressure on the ground than on the table. Huh? Can we say
Yes.
this?
Yeah.
So the same idea we are using for uh, this one. You see, the top of the mountain we have uh, less number of air molecules working per square area, and on the sea level or on the ground it's more, right?
Yes.
That's why the pressure will be more on the ground than on the mountain. Is it
Okay.
clear?
Yeah.
Okay, is it clear to you now?
Yes.
So this idea here we have, I don't know, previously you got the explanation this way or not. But you might know that at sea level the atmospheric pressure is more,
Yeah.
and the top of the mountain the atmospheric pressure is less. But why it is that explanation, did you know before?
No.
No. Today you got it, and I think this way you should learn, right? By
Yeah.
the explanation why it is. Then it will be more understandable to you, and you need not memorize, it will come automatically in
And it
your
will
mind.
stay in my mind for longer.
Yeah. So here we got that one. So you write here atmospheric pressure, this heading you write. Then you write here the atmospheric pressure is the air pressure. The atmospheric pressure is the air pressure.
The atmospheric pressure is the air pressure.
Yeah. In other way around, you can say atmospheric pressure is the force per unit area by air particles. Okay.
Okay. Done.
Uh, okay. So you write also the atmospheric pressure is most at the sea level. The more we go up, the atmospheric pressure decreases.
Okay.
The atmospheric pressure is most at sea level, and the more we go up, the atmospheric pressure decreases. Now we have the instrument barometer. Huh? Barometer, write the heading barometer and then draw this diagram. Huh?
Okay.
So barometer is one instrument which is used to measure the atmospheric pressure, right? Atmospheric pressure, okay. Mhm. So done, this drawing is done.
Yes. Uh,
Yes, done.
yes.
So here we get the idea if the air atmospheric pressure increases, if the atmospheric pressure increases, then the pressure, air pressure is working here downwards, right, on the liquid,
Yes.
which pushes the liquid upwards inside the tube, right?
Yes.
And there is another thing we have here vacuum. So in this vacuum, if we have other things other than vacuum, if we have, for example, air, then
It will
this
explode.
mercury level will not be able to rise up,
Yeah.
isn't it? It will rise up for a while, but when the air is compressed too much, then it will not allow any more mercury to go up, right?
It will stay fixed.
Yeah. So our reading will not be accurate that time, right?
Yes.
So sometimes it comes why we have vacuum in the barometer. That's why you're having this idea. So the other things you'll understand. Now we have manometer, huh? Manometer. Manometer, as for our previous discussion, you told that you have some idea about manometer, little bit idea, right?
Yeah.
Manometer is a device which is actually used to measure the gas pressure by using the difference in height of two liquid columns, right? So you draw this diagram of manometer, then you write this definition of manometer, and this formula is very important. Del P equals P minus P naught equals rho g h. So gas pressure, they wrote here gauge pressure. It should be actually gas pressure. Gas pressure equals uh, you see, we have here atmospheric pressure, and the this tube is open, right?
Yeah.
So this tube is giving you the this side we are having the atmospheric pressure, right?
Yes.
So atmospheric pressure we are having here. Then we have fluid of interest, gas in most cases. So we have here the gas pressure working, right? And this gas is pushing this liquid up. And normally, uh, if we have like this, for example, if it is like this, then your gas pressure and atmospheric pressure is equal, right?
Yes.
So if you want to have more, pressure, like the pressure is more from the gas, then this will push more, right? The liquid level
Yes.
will go up this side. Then this difference is giving you the extra part. This is more than atmospheric pressure, right?
Yes.
So here the gas pressure. So here the gas pressure will be P. Actually, it should be P. P equals rho gh plus this formula you don't write. You write another way. I'm showing you. You write P. P is the gas pressure. You write gas pressure. Then you write P naught. P naught is the atmospheric pressure. Okay. Uh, then you write plus rho gh. Directly you write this way. Don't need to write other things. Then it will be confusing for you. Okay. This much you write. You write here gas pressure. You draw this diagram and write here gas pressure. So I'm writing in text. Writing in text, that will be easier. Gas pressure. Gas pressure. Okay. Gas pressure P equals P naught plus rho gh. Is it clear? Hello?
Yes, sir.
Advita, is it clear to you what to do?
Yes, sir.
So draw this diagram, write this equation, then write this definition. That's it. About manometer, this is enough.
question.
Yes.
That is, it says fluid of interest, gas in most cases. So if we use liquids, should the two liquids be immiscible, or will miscible liquids work as well?
Actually, whatever I saw till now, we have here measuring the gas pressure, and for measuring the gas pressure, we are using the liquid. Liquid is also like we are using water or mercury. Okay, most of the cases we are using water because it's bigger, right? Bigger
Yeah.
manometer and gas pressure. So mercury will be more expensive for this purpose, right? That's why water is used.
I'm talking about the fluid of interest.
Yeah.
I'm talking about the fluid of interest.
Okay. So fluid of interest.
Can we use liquid? I mean, if so, then how? Then should the fluid of interest and reference fluid be
Actually,
miscible or
no, no, no. Actually, fluid of interest means fluid. Here, we say gas is also one kind of fluid, right?
yeah, fluids
So
both liquids and gases?
yeah, both liquid and gas are called fluid. So here, fluid of interest means gas.
Uh,
Most cases means you can say 100% cases we are using the gas because the manometer is used for measuring the gas pressure.
when it's said most, I got a little confused.
Yeah, yeah,
I'm done with the diagram and everything.
yeah. Writing is done, right? A manometer, this one definition. This definition also done. Hello, Adrita.
Yes, sir.
Okay, definition is also done. Okay, good. Then we are going to now next. Okay, so all these things, whatever we discussed, are coming in here. Discussion, you just take.
Okay, sir.
Now, now hydraulic systems. Yeah, hydraulic systems. How does it work? We have here this formula F1 by A1 equals pressure, and here the pressure is P1, and this liquid, uh, as as we know, it is liquid, right?
Yes.
So this liquid level, like the height of the liquid, we know if the height of the liquid is same, the pressure applied by the liquid also same, isn't it?
Yes.
And using that principle, we understand the pressure for both the ends, opening ends, will be equal,
Okay.
isn't it? Now, now for this left side one, we have the force, uh, that is area is small, right?
On
Area
the
is
first one,
small.
right?
The left side one, the area is very small, right?
Yes.
And if we are getting the force divided by area, the pressure we are getting here, the same pressure we'll get here, isn't it? Now, what we are getting here, area is bigger, as the pressure remains same both the sides, and due to this
Well,
area is bigger, the force, this one F2 will be also larger now. As the area is larger, we have F2 by A2 is pressure. To have the same pressure, we will have here greater force created here. Is it clear? Hello? Hello? Is
Oh,
it clear? Is it clear
yes,
to
sir.
you?
Yes.
Yeah, so we are having the formula here, uh, and uh, I would give you one numerical example also here. Like if we have here the force 10 Newton, here the force is 10 Newton. For example, 10 Newton, then an area, for example, here 2 centimeter square. For example, it is 2 centimeter square. Then we have here area ten centimeter square. So what will be our force? We have to calculate force F2 will be found by using this formula A2 F1 by A1. Then A2 F1 by A1. If we write, what is the force coming? Our A2 is given 10, then our F1 is given 10 Newton divided by 2. Then the answer is coming 50, right? 50 Newton. So force is coming now 50 Newton, which is 5 times than before, right? We are applying only 10 Newton, but we are getting here 50 Newton output using this hydraulic pressure. Is it clear?
Yes.
So you please write this heading hydraulic pressure or hydraulic press, whatever you are saying, hydraulic press. So you draw this diagram. Yeah. So hydraulic press, how it is working, we understood. Same way, we are getting this application here in this application. You see, these are actually in industrial purposes. We are getting these kinds of hydraulic press, then hydraulic brakes we are getting the same principle we are using. Yeah, we are applying here very small force, then we are getting here greater force, right? You
Yes.
understood, right? Then
Yes.
we have Boyle's law. Boyle's law is the last learning outcome we had, that is P1 V1 equals P2 V2. We understand one thing, that if we have like in your classroom, you think if you have only 5 students, then these 5 students you can sit with some gaps, right? Isn't it? Hello? And
Yeah.
if you have now in classroom around uh, 30 to 40 students in the same classroom, then what will happen? They,
There will be more.
yeah, the number of students are more, and they will, you know, scatter, right? And they will be colliding with each other, and also they will be, feel much more hot, right? Isn't it? And in other way around, if you think that you are only 5 students, now you can sit nicely in your classroom. Now, if we make this classroom much more smaller, like the one we have now, if the space is, for example, 1/4, what will happen? You will be more closer, right? Isn't it?
Yes.
And if you are more closer, then you are more likely to go much more closer to the walls, right?
Yes.
And what happens for gas particles if the temperature remains constant, if number of if mass is constant, mass constant means number of gas molecules are constant, right? So that time what will happen? The gas molecules, they are very close to the walls. They are having less space. So the way the way they were colliding with the walls, now the colliding will be more, right?
Okay.
Like
Yes.
in 1 second, maybe they had before two collisions. Now when it is going 1/4 of the volume than before, then the number of collisions will be now 4 times, right? 4 times, isn't it? Like in 1 second, 4 times they will, 4 times it will collide, then it will be eight times colliding, isn't it? Hello.
Yes, sir.
So this way, their collision with the walls will be more. If the number of collisions more, that means they are applying more force on the wall, isn't it? Container wall. If they are applying more force per unit area, then the pressure is more, isn't it? Hello,
Yes.
the pressure is becoming more. Then we can say the volume and pressure, they are inversely proportional. If volume decreases,
Mm,
yeah, if volume increases, the
pressure
pressure
decreases.
becomes uh, less, right? If
Yeah.
the volume decreases,
Pressure
the pressure
increases.
becomes more. Okay, is it clear now?
Yes.
Now that law is given by Boyle's. That's why it is known as Boyle's law. Okay,
Okay.
so you write here Boyle's law, and write this. Boyle's law states that the volume of a fixed mass of gas at constant is inversely proportional to the pressure applied to the gas. Then you write this formula. P is directly proportional to 1 by V. Then V equals constant. And we have P1 V1 equals P2 V2. Huh?
P equal to constant. What does it mean? The second line
Yeah.
of the
Second
formula.
line you write, and the third line also you write. That one is our learning outcomes giving, right? If you have PV
Could you
equals
explain
constant,
this
then
line?
if you have PV equals
This
constant,
one.
that means yeah, this one is here. You know, anything if it is like you have, if you have in numericals, mathematics, like A is directly proportional to B, right? If we get
Yes.
this, or inversely proportional, whatever is said, then we have A equals, normally we give A equals KB, huh? KB, this way, where K is proportionality constant, right?
Yes.
And here we are writing only constant.
Oh,
Is it
okay.
clear?
Yes.
So this constant is proportionality constant.
Okay.
Now, if you have PV equals constant, you can write P1 V1 equals P2 V2, because this multiplication is always same, right? You will have P1 is directly proportional to 1 by V1, then P2 is directly proportional to 1 by V2. This way, for all of them, you will get the proportionality constant same, right?
Yes.
Isn't that? That's why we will have P1 V1 equals P2 V2.
So we just have to learn this now.
This
We don't
much
have
is
to learn
done.
temperature, volume, or pressure temperature laws.
Yes, this is enough for you now. We
Okay.
will learn them later, okay? About the temperature is changing and the mass is changing. That one we'll learn later, okay?
Okay.
Now only we are having the relationship of pressure and volume when mass is constant and temperature is constant. Okay?
Yes, sir.
And you have one test left, that is turning effect of forces. In next class we want to have that test.
About next class. Actually, exam starts from the first, and on 6th and 7th I have few maths tests. So actually, I was going to ask you if we could do the class on next Saturday or Sunday later.
Okay, you have exam on Sunday.
Yeah, Sunday and Monday sets are really difficult, so I'll have to spend a lot of time practicing, and I don't think I'll be able
You
to do
you
class on
have
Saturday.
exam on Sunday, right?
Yes,
Maths.
yes.
Then on Monday, what you have?
Additional math.
Additional maths you have. Then on Tuesday, what you have?
On Tuesday, uh, sir, wait, let me check the routine.
Yeah, check it and then tell me on Tuesday what you have.
Okay. ও অ্যাডমিট করে করতে পারবো, মঙ্গলবারে বন্ধ আছে।
Yeah, Tuesday it is closed.
Yeah.
Tuesday no exam.
Tuesday I don't have any exam.
So Monday you will have that class. Will it be okay?
On Monday?
Hmm?
Yeah.
After school, after exam, you can do, right? Because Tuesday
Yes.
you are free, so that will be better. You can have the test also, right? Turning effect of
Yeah.
forces. So on Monday you will have class uh, after Maghrib, okay?
Okay, sir.
Not before Maghrib. It will be 5:45.
Okay, sir.
5:45 to 7:15.
Okay, sir.
This 1.5 hour you'll have. So uh, that's done. Okay,
Yes,
that's
sir.
it. Okay, okay. Allah Hafiz.
Sir, sir, okay.